Hi, this is Temp Dev Podcast where we explore ways to consistently deliver differentiated products and services. Today we have Jason Kridner with us from BeagleBoard.org fame. And BeagleBoard.org has been instrumental in open hardware and education. And we'll learn a lot more about the idea behind BeagleBoard.org and what all projects they are taking up to. So, hi, Jason.
Hey, Kim. Hey, Cliff.
Hi, Cliff. Okay, so Jason, tell us about who you are and what's your career looks like so far.
Okay. I spent a lot of time in the semiconductor industry, so um, I've kind of did all sorts of different roles. Everywhere from development board, um, design work stuff, but I did a lot of FPGA, ASIC design, simulation, right? So a little bit of chip design, chip architecture, but mostly I did apps, right? And so apps at a semiconductor company is where you kind of teach people how to use the chips, right? The things that you make. If they're processors, then you teaching people how to use processors. So most of my career, I spent teaching people how to use digital signal processors, right? So that could be in MP3 players. Went into a lot of MP3 players, portable media video players, like that sort of DSP stuff. Um, you know, Worked on supporting video codecs into cell phones, right? As cell phones became like a big application of DSPs, and and then I got kind of in my career at TI, I got a little bit of a wild hair that I wanted to try to improve access to the cell phone technology, right? So TI had a really nice position around the first superscalar ARM cores, right? The Cortex A8. And that's kind of where BeagleBoard really kind of took off, right? Where ARM was just starting to become um, accessible and capable of doing desktop-like tasks, right? Have much higher performance as cell phone processing demands were skyrocketing, and I saw that as an opportunity to like wow, I can actually like build a real computer out of this, right? Something that looks and feels like a computer rather than something that it's a computer. You look at microcontrollers, right? It is a computer, but it doesn't feel like a computer, right? You can't do native hosted tools on it. I can't work with it the way I work with my desktop computer, where it's like I'm not making programs on it, right? I'm using some other computer system to make programs for it. And I saw that as kind of an opportunity to kind of bootstrap things and get out from underneath a lot of tooling that was being done for embedded systems that, in my opinion, was rather arcane compared to the development that we had for kind of native systems, right? And that was pre Yocto project, just slightly, but Open Embedded was out there. Met Kun Koi, and oh my gosh, what he did with the Open Embedded on the original BeagleBoards was just absolutely amazing. Can't not sing his praises enough. Um, um, it was a huge part of the early success of BeagleBoard. But so I started this nonprofit to kind of moonlight on my own um, personal desires to go and create computers that were you build embedded systems out of it, right? You build in like products, appliances, not just applications for somebody else's platform, and to give people a different way to go and develop. And it's always, BeagleBoard has always been about kind of respecting engineers' time and not assuming that they're electrical engineer or computer scientists, right? So, right, they're just coming at computers to solve a problem, right? They might be a chemical engineer or not an engineer at all, right? They might be an artist, right, trying to get some motors to move. But for anybody to kind of respect their time, that focus on education, right? It's not just it's not just making it easier for kids. It's making it easier for real engineers as well, who don't have the time to go dig into specialized tools for every platform that they touch. Right. So we really try to enable people to develop in the ways that they're already used to. All right, if they're doing some desktop code, or they're doing some software for any other environment, and they just want to turn it into, I keep using the word appliance, right? So something where the technology kind of just gets out of the way, right? It's just about having a machine that does what you want to do when you want to do it. Um, and and that's what we try to make it. BeagleBoard is the tools that do that. Now I'm no longer a TI. We're doing non-TI boards, CI boards. So like RISC-V, I think, is really at the cusp of where ARM was when we started BeagleBoard. Right? It's you could do you can build desktop computers out of it. Right? You can use it. RISC-V, right, in new ways, and so like we're doing a lot of focus on RISC-V, but we're still doing a lot of other work on ARM, and now I get to actually spend time working on the fruits of my labor at BeagleBoard to go and serve people's needs to go build appliances, right? So I have my own consulting business where I try to do kind of turnkey hardware plus software, right? So for different things, most of that is in kind of the IoT space right now.
Mm-hmm. Sure. So back when you started, was there any open hardware like the BeagleBoard, or was the BeagleBoard like the first one that came on the scene? I'm trying to remember.
Yeah. So there was open hardware really wasn't a term when we started it, right? So when at a semiconductor company where you don't really care about the protecting the hardware design, right? You made reference designs, right? And that's what you called it. You called it a reference design. You gave away the layout. You gave away, documentation information about how to reproduce that into something. And we didn't have the term open hardware at that point. Yeah, so it was more of a reference design. There was you kind of had two kind of camps. You had the proprietary development boards, or where everything was closed off to you, and then you had reference designs, which you couldn't actually get readily, right? There was like small numbers of reference designs built.
Yeah, and I remember they were often very expensive too. Back in the day, they were hard to get. They weren't real accessible and very expensive, is my recollection.
Absolutely, and so where we kind of crossed over was getting into like more widely usable applications just as a computer, right? So the kind of the class of single board computers kind of emerged with BeagleBoard, right? There was a lot of module computers, and there was like otherwise you kind of bought things in enclosures, right? But the modules were designed largely to go into some other type of system. And that was really popular. I think Gumsticks is the one that comes to my mind. But there was a lot of, if you go into the magazines, right, there was just all sorts of people providing these, module-based systems. But single board computers so much weren't a thing at the time that BeagleBoard came out. And then, of course, the Raspberry Pi came along and really popularized this concept of single board computers, and BeagleBoard benefited from that tremendously.
Yeah, I think that BeagleBoard, the XM and it really, I think, seeded the SBC industry. That's what I think. It was first one to come out with something like that, and now I think SBCs are so common.
And it was much copied, right? There was,
Yeah.
we got to the animalboard.org, right? So everybody was trying to kind of copy the pattern.
Yeah.
And it became a really nice pattern. We did some things right with BeagleBoard, making it a nonprofit, making it not, making sure that all the stuff that we were depending on was stuff that was going to be available long term, and that was actually like available through distribution and things like that. So it didn't just disappear, right? So BeagleBone Black has been in production since I think 2000. Well, the original BeagleBone I think was 2010. I think in 2012, the 2012 or 13, BeagleBone Black came out, and it's been in production ever since, right? And each year we make more of them. So so just millions and millions of BeagleBone Blacks have been built now, and people use them all over the world to all sorts of things, right? They're used in satellite networks and in space, right? The space one just kind of just like amazes me a bit, right? To go and like watch all of a sudden you flip a National Geographic special and you see your board in a Europa rover prototype. It's just like, this is, I've arrived, right? This is,
I think the Beagle boards, I think, one of the issues in SBCs are, they kind of like come and go, so basically Beagle board, I think, has been one which basically you could rely upon that it's there. It's being provided with like, is still going on, and you can still rely on for supply, years after its design. So I think that's one thing unique about it, among other things. So what's like some of the current, I know there are many boards that I think BeagleBoard.org has come up with so far. So what's the, the current status? What are different Beagle boards out there?
I'll feature, I don't know. I think maybe I'll just talk about two. The Beagle Y AI, right? It's in a Raspberry Pi form factor. It's our first foray into making Pi form factor boards. But it's still very much a Beagle, being open hardware, and I'd love to talk more about like why open hardware is important and what that means. And some people choose to do single board computers as open hardware, and other people don't. The Raspberry Pi is not open hardware, even though it runs open source software. It itself is not open. But the Beagle Y AI is built around a Texas Instruments ARM processor that has neural network accelerators, and it also has R5 microcontrollers, 800 megahertz microcontrollers in it for doing real-time I/O operations. And it's kind of got the standard fare PCI Express and the 40-pin hat connector, CSI, DSI, inputs and outputs, HDMI, USB 3, super speed, gigabit Ethernet, power over Ethernet, Wi-Fi 6, so it's got kind of all the stuff you'd expect to see in the latest, contemporary single board computer, quad core 64-bit processor, 4 gigabytes of RAM, right? But then it's also got these extra bits that are really common to Beagle things, right? It's I think what a lot of Beagle gets associated with is kind of the extra stuff that you need if you're going to make kind of real world embedded systems, right? Having the DSP in there for doing the neural net stuff, for getting the performance that you need to be able to do that at reasonable price and power, and then things like the microcontrollers in there for doing the real time I/O. Right, we've been playing a lot with Zephyr. We've got a the TI Yocto SDK, we can use that, to target the systems, right? So yeah, it's like a Pi. In fact, I spend a lot. Putting it in a Pi form factor has been actually really liberating. Just because so many things have been kind of built. So like, I want to put it in a robot arm. I can go buy a robot arm off the shelf that's been built around a Raspberry Pi, and just throw, kind of kernel, device tree, bootloader on it. In the FAT partition, and then just run the file system and then start doing customization from there. So kind of getting those pre-built systems and just being able to extend and augment them, right? And you get a lot of compatibility just out of running Linux. So being able to just kind of plug it into things really quickly has been very, very liberating with using the Pi form factor. So that's definitely one that I'd really highlight from BeagleBoard, is the BeagleY AI.
Mm-hmm.
And if I wanted to highlight one other board, I'd say it's the Beagle 5 Fire. That's our first FPGA board.
Mm-hmm.
And it's RISC-V based, right? So it's using a microchip Polar Fire SoC. But it's got the BeagleBone headers on it, so you can you get a lot of like kind of the low speed I/O, but it's also got an M.2 on there for doing PCI Express, high speed I/O, and it's also got a syzygy connector on there for a lot of high speed I/O. So if you want to do things like software defined radio, you've got the I/O bandwidth that you need, and on an FPGA device. And we've been doing a lot to try to, so the open FPGA toolchain itself, right? We're just getting started, kind of working on some things there. But what we've done is we've got the Open Beagle GitLab instance, and we've got GitLab runners running the tools. So if you want to take the existing Verilog project for interfacing up to the Cape headers or to the M.2 or to the syzygy connector, right? You can just modify the Verilog and push your project through Git and just use our builders to kind of rebuild the gateware. And then right there on the RISC-V cores, right, running Linux, you just run a shell script and you reload the gateware, right? And it's a flash-based gateware in the Polar Fire SoC. So when you reboot it, it automatically just comes up with the gateware loaded, right? So it's kind of an instant on thing. And so it gets, if you have a system where you need the FPGA fabric to be loaded, at power up, having the having the flash-based FPGA is super, super useful for that. And it's nice, low power, very, robust, and RISC-V cores, right? So it gives you an opportunity to kind of play with RISC-V and FPGA technology. So
awesome. Yeah, and what are some of the products you mentioned about briefly where it is being used? But I'm curious about where all is BeagleBoard being deployed and used. Is it educational, industrial, other places?
I think from a volume standpoint, it's mostly being used in kind of commercial automation. Most of the people buying Beagles probably buy 1 or 200 a year, like in terms of like people like pushing the volume, right? There's a lot used in education, but a lot more volume. I'd say that the mix has changed over time. And a lot of people kind of went to college, learned on BeagleBoards, and then came out and started building industrial automation tools, right? So everything from cheeseburger robots to COVID testing machines to I've started collecting things with Beagles in them to some extent. So I've got a laser cutter driven by a Beagle. I've got a CNC mill driven by a Beagle. I've got a PCR, which is like that I mentioned, the COVID testing, right? So it's a machine that it's called Open QPCR, and so they actually released the open source the whole design for this low cost PCR machine, which was really useful in like detecting COVID in the early days, right? So it's made it much more affordable for people to be able to kind of scan work areas and things for the virus. What other fun toys do I have that are products? Oh, I like going into the Slowpokes is a coffee. It's like a if you've ever been to the Slowpokes chain of cafes, they're pour over coffee machines that's driven by a Beagle, right, by a company called Pour Steady. All right, so so coffee machines, robots, cheeseburger robots, a lot of that sort of automation things, right? So where you have a kind of a mix of real time, like moving the laser head and the Dremel laser cutter to presenting some type of UI, right, graphical UI on a screen, right? So having that combination of Linux and low level, and now we're supporting a lot of the low level programming with the Zephyr RTOS. All right, so that's been it's been a lot of fun, right? So and we're even running Zephyr on like the A53 cores, or like the 64-bit ARM cores as well, not just the 32-bit, and on the RISC-V, both 32-bit and 64-bit RISC-V cores. So like if you go into upstream Zephyr now, you'll see Beagle 5 Fire in there, and we're working on putting the Beagle YAI in there as well.
Wow. So to summarize, it seems like the Beagle products really focus on more options for I/O and low-level interfacing than like you would have on a Raspberry Pi, where all you have is the host CPU and nothing else to kind of do real time or anything like that.
Absolutely. And we try to enable people to go deeper, right? We want to try to keep the easy things easy, but it's about making the hard things possible. Right? Not necessarily the hard thing's going to be easy, but by being open hardware and by working with companies like Microchip and Texas Instruments that actually provide detailed documentation and availability of their chips, right? That you can dive deeper. And so from an educational standpoint, I find that really, really important, right? So that there's not a limit to how many layers of the onion you can peel back. I know that there are some IP cores that do have challenges, right? Like the GPU. Like one of the things we've kind of spearheaded is working with Imagination to get open source drivers, and you see that Imagination has released a ton of documentation and been working a lot with Mesa to provide open source drivers for the GPU as well, like going to that extent, right? So having those extra layers that you can peel back and have a deeper understanding with being open hardware and kind of beyond open hardware to working with chip suppliers that actually document the chips, right, I think is a big part of what makes Beagle different than something like a Raspberry Pi, where you can't buy the chips from Broadcom, you can't get the detailed product manuals. If you wanted to spin a board, right, like spinning a board is just one part of it, right? You can do that with Beagle. You can spin your own board, and we are working on like it can show you a work in progress, right? Things like modules to try to make it easier, right? So like these things are being used today and are going to show up in distribution soon, right? So that if you start with the Beagle design, kind of you can just take and make your own board out of the Beagle design itself. But if you want to build a board, all you want to do is like change connectors, right? You don't necessarily want to lay out the complicated things like the DDR, even if you can copy it, right? You just don't want to deal with that complexity in your board design. You can take the baby step of a module.
Mm-hmm. So how is BeagleBoard.org funded? And,
Yeah. So we don't do any manufacturing ourselves. So we work with partners, primarily Seed Studio, but also GHI Electronics. And they are our manufacturing partners. And so they license the logo. So the foundation, it's entirely a nonprofit, owns the trademarks, right, to things like the logos, right? And, in exchange for, the usage of the logo, right? So on products, the foundation gets a royalty, and that's kind of like you're joining the club, right?
yeah.
Right. So you join the foundation and support it through purchases of hardware. We do accept donations as well, and people do donate. I think about maybe 15% of the comes from like just direct donations versus royalties. So royalties are by far the most the biggest way that the foundation is supported, and then the foundation money goes towards development of new designs and documentation. Right, most of the the resources is go to documentation and and then most of the forum support is volunteer. Folks like Robert, who's a board member, he's as far as Beagle, he's fully volunteer, which is amazing for how much he does with the Beagle community. Right, he has a day job at DigiKey, and then we love everything Robert does to support the community. But if you have a question on the forum and you're not getting answers, I publish my calendar, and I just ask if you put the question on the forum, right? I'm not going to answer your question without being paid, without it being a public thing. So if you publish it on the forum, then you can, and you don't get a good answer in 24 hours, put something on my calendar, and I'll make sure to get an answer out to the forum, right? So escalate it through me, and if I need to, I can escalate it to Texas TI or to Microchip, right? If that's what's needed.
Yeah, that's cool. And if there is any donation link, we can put it in the show notes as well.
Cool. I'll definitely provide that. Right. The easiest way to find it is on the about page on the website.
Okay. So moving on to the software side, Cliff and I, we do a lot of open source. So our heart and mind also is always looking for what people are doing in open source world. So how would you define the role of open source software in BeagleBoard ecosystem? And what would be an ideal, what would you like to see in terms of software ecosystem on BeagleBoard?
All software is welcome, right? So, no limits, no discrimination, really, right? All software is welcome, but we focus our efforts primarily around Linux Foundation projects, right? Because we just interact so well with that community. And that's things like Linux, the Yocto project, and Zephyr, right? So like that's primarily where we'll put most of our time or focus most of our efforts around our Linux Foundation software projects. And like the open source software and open source hardware to me are just like a match made in heaven, right? And it's when you look at education, right? I think that it's again, it's like peeling back the layers of the onion, and the way that we have these Git repositories really give you a process where you can go and all the public discussion, right, where you can understand why things are done the way they're done, where it's coming from, and then make it better. right? So when we do like our Google Summer of Code internships, right, we really try to teach people how to contribute to the mainline projects, right? We try to work with suppliers who understand the value of working upstream, right? We try to promote that into the suppliers, TI and Microchip, which I think are generally pretty decent stewards of open source, right? I think there's always room for improvement, and we'll keep reminding them of those opportunities for improvement. We try to provide them with a good showcase for their technology, and and keep encouraging them to do that support, right? If it's Yocto, if it's Linux, if it's Zephyr, and focus on utilizing open tool chains like OpenOCD and GDB, and all these proprietary tools that these companies have. Great, more power to them. It's just not of interest to Beagle, right? And that doesn't really, it's all helpful for our community, but it's not necessarily where you'll get focus from Beagle folks, right? It's going to be on what can we do with open source technologies.
Yeah, that's great to hear that you're promoting the upstream first mentality, because that's some of the biggest pain we run into product development is companies that don't really try to keep their support pushed upstream, and these long-term forks develop, which become very difficult to maintain. So
absolutely, it's the only way you can kind of get longevity, and longevity is important both for education and also in terms of product development, right? It takes time to produce things, and I think everything that we're doing at Beagle, right, is focused on the long term. It's nice to see folks like Artem, Aginsky, who product manager for the Centaur product line at TI, right, come out and talk about the benefits of mainline first strategy, right? So it's like when they're parroting it back to you, right? It's nice to know that they actually get the value, right? And it's going to reduce their support burdens long term, right? I think there's a lot of companies kind of producing technology kind of get this mistake that it's their tools and these other things that really set them apart and differentiate them, and that they need to keep things closed, and that support is going to be easier if they don't try to support these open solutions, and they just provide their one special blessed kernel or their one special blessed software distribution, and it's nice when they figure out that's wrong, right? That just makes everything in their life harder. And if they just actually go and support the people pushing things into the main line, that everything gets easier.
Yeah, so I think what's your thoughts on designing good open hardware?
Oh man, thoughts. I'd love if we had better tools for developing open hardware today. I love KiCad, and we're doing more and more developments in KiCad. But it's the tools haven't caught up with kind of modern DevOps, right? In terms of like Git, and like they're reasonably text formats, but like, do I really need a visual schematic, right? Instead of like really collaborating in our net list and communicating like architectural level decisions, right, in a way that can be crowdsourced, right? It's not there. So very, very happy for people to show up on the forums and communicate their ideas about what they'd like to see, and but I don't think there's like a a silver bullet or magic thing that says like what makes a good open source or hardware project, right? I think you trying to stay connected to the developer community, see what type of solutions that they're doing. We try to do a little bit of thought leadership at Beagle based on problems that we kind of keep seeing, and I'd say we have mixed success and kind of pushing out some of those things.
Yeah.
We did one of my favorite boards, the Beagle Play, where we kind of took away the we don't have like the big expansion headers, so we just put this thing called microbus, right? And everything kind of comes to standard buses, Groove or Grove and Quick, or Stemma QT, however you want to call them, right? Where you could just kind of buy sensors off the shelf. And we've been working for years now on improving the status of support for all of these sensors in the Linux kernel, right? So we kind of settled on microbus as kind of the one that we want to kind of put the most effort behind, and kind of looking at this technology, Graybus, which a lot of the Graybus stuff got developed on BeagleBones themselves, back in the day for Project Ara, which was the kind of the mothballed project for making modular mobile phones, which I absolutely love, right? And that's exactly the sort of like modular mobile phones and Project Ara, right, is exactly the sort of thing that I would hold up as to kind of be the ideal of like what we could create in a perfect open hardware world. But it takes but practically it just wasn't there, right? The economics didn't fully support it. Right. So decomposing the problem a bit, right? Proving software for we spend a lot of time. I'll tell you what I don't like, and that might be a better way to kind of get some of their, like a lot of times it's just kind of the things that turn my stomach, and it's people writing Python code to send I2C commands to work with various sensors, and I get it. I understand why you would do it, but it's if you know the part, you're trying to build up the driver itself, like it's kind of a quick and easy kind of way to hack. But it inevitably it ends up with code that's just broken, right?
Yeah.
And nobody can maintain because there is no upstream kind of making it robust and solid and making sure when anybody in the world finds a bug, they know where to fix it. And having those bug fixes consolidated, right? Like that to me is the magic of the Linux kernel, right? It is like the repository for bug fixes, and random Python libraries and on PyPy don't have that, right? And you cross your fingers and hope somebody fixes something on there, but it's it's a 3 levels down, somebody threw an exception that the guy that writing the library never handled. It's a recipe for disaster, right? Definitely a house of cards, right? So like by pushing things into the mainline Linux kernel, right? So we keep going back and forth on how do we define connector specs, but that's what we're working on, right? So we worked with Microelectronica to put into all their click boards, right? These little add-on boards, right? They have about 1,500 of them or more. I think they release 1 or 2 a day. So you should be able to get one of these boards for like whatever sensor you might want, sensor, actuator, indicator, network connection, whatever it is. Because it's a really easy standard to work against. And so we're trying to push into the Linux kernel the way to go. And so I kind of skipped this part. We worked with them to put IDs on each of these. So on boot up, you can probe these things and find out what they are. And we defined a manifest format that would actually load the driver for that as well. But that didn't get merged into upstream, right? So we're still working on kind of redefining that. But the identifier is there. You can override if you need to. But so working with the Linux community to define, okay, if it's going to be a device tree overlay, it needs to be generic, right? It can't be for a Beagle, right? It has to be for all boards that have a microbus connector. And so ideal open hardware for me is one that encourages people to work with the upstream, and doesn't encourage people to go and grab random Python libraries.
Very well said.
That was a very long-winded thing to say.
No, that's great, because the Linux kernel is really, supposed to be the hardware abstraction system. And once you break that model, then things don't work very well. And so I appreciate that.
For us, writing a kernel module doesn't necessarily seem that complex, but I think for a lot of new people it is. And I think we continue to. I love what we did with Beyond Webster and the Embedded Apprentice Linux education, or Embedded Apprentice Linux Engineer program, teaching people basics of writing I2C and SPI drivers, right? Those sort of efforts really are ideal for me, right? So the Linux Foundation, right, gives those trainings and the full trainings, and working with the folks that kind of do take some of that stuff and do it at more local levels and stuff, I think is wonderful. But writing a kernel module is really not that hard, and if you've done it, you know that. But if you haven't done it, it can be pretty intimidating, right? It's it's just a program that has a couple special entry points, right? Right. That's all it is, right? And you don't need to reboot the machine to do it, right? You compile a module on your running machine, and you load the module, and it runs, and you unload the module, and if you want to do some I2C accesses in there, go for it.
Sure.
So I understand why it's intimidating for people that want to write Python that does I2C transactions, but don't be so scared. If you get it into the kernel, it's going to be debugged, and it's going to live forever, and it's going to be so much better.
And maintained.
Maintained.
So with open hardware, you've mentioned it's really important to what you do, but what are the benefits to your customers that open hardware brings? I mean, we've talked about a lot of them, but maybe it might be useful just to kind of summarize why is open hardware so important in these types of systems?
Yeah, I think the electronic shortage of the COVID really taught us a lot about managing supply chain. Things that at BeagleBoard and other places, right, we kind of already knew, but it brought it home to a lot of people. Having ownership of your supply chain matters, right? If you're trying to build products, right? Understanding what technology you're dependent on, who's supplying that technology, and having a relationship with those suppliers so that you get taken care of when there's crunch times, right? And actually working on planning. And just buying a off-the-shelf SBC from random company without a supplier agreement is probably not going to take care of you in hard times. So so having open hardware, means that nobody's holding you captive, right? Or at least wherever you are held captive, right? I mean, you still, okay, this is dependent on a TI SoC, right? You can go and talk to TI, or you can just know where your limitations are, right? If you need to design somebody else who's a bottleneck out of the board, right, in order to get to stay in production, or you can do that.
Yeah, it's really some of the same benefits as open source software. Really, you can be part of it.
Yeah.
You have some level of control that you don't otherwise.
You can fix it.
Yeah.
You can. You don't have to rely on somebody else to fix it. Yocto project is just this massive array of fixes and fixes and fixes for other people, right? That hopefully land upstream at some point. So it's I think it's the only way. If you're doing business, I think it's kind of the only way. And same for education, right? Right. If you don't want to get in a situation where, somebody, they don't want to make that anymore, right? They're not making enough of them. But if I'm teaching a class in the fall, right, and people can't get a hold of them, it's a problem.
Yep. Yeah. And I think that the tools in software, open source software, probably, there's some learnings we can take from there into hardware. Like you mentioned Git, and, some of those processes are really battle tested so far in software world. And I guess, those practices, bringing them into open hardware designs and can help as well, I think.
Yeah, some of the tools I think really need a lot of improvement, right? But like we manage all our board designs in our GitLab and Git repositories. We mirror them up on GitHub, and we take bug fixes from the community, bug reports, open issue, like they're public issues, right? So people know what things are broken, need workarounds and things, and people do submit hardware fixes, right?
Yeah, that's my question. So you've actually got a pull request for hardware.
Yes.
That's wonderful. Yeah, that's amazing.
Yep. They're very few and far between, but yes.
Yeah, it's at least possible.
Usually it's more the issue report that's kind of the critical item, and tracking that to closure. But sometimes people actually do take the effort of actually modifying the design and submitting back the modified design. But like a diff and Allegro, forget about it, man.
Sure.
Forget about it. It's just a binary blob mystery. KiCad's a little bit better, but it's so hard. These tools are just not made for that sort of maintenance, right? So. I mean, at least I think schematics should be a lot better, right? We really shouldn't. I mean, the graphical representation stuff is nice, but a readable net list shouldn't be that hard to do. I don't know. I should stop talking about it, or I'm going to end up giving myself a project.
Sure. Yeah, it's your chip design background, no doubt, affects that. Where we now use Verilog and other text-based description languages for hardware design. So there's really no reason we couldn't do that for PCB design as well.
Yeah,
absolutely.
So I think the one question I have, I'm dying to ask is, because you have designed ARM-based hardware and you have designed RISC-V based hardware, and I know there is a lot more that goes in. It's just the ISA doesn't cut the chase. So essentially, what's your experiences of working in the both, like say a RISC-V based part or ARM based part? How do you see it in future?
There's so many different ways to answer that question. I'm not sure which one you're fishing for, but I do think the world's moving to RISC-V. It's just a matter of time, right? If you get I don't see any reason why people should be scared of RISC-V. The tooling is pretty mature. I'll tell a little story we have on the BeagleBoard Ahead, which is our highest performance RISC-V board. And the people that made the SoC, they actually made a fully open source version of the CPU. So the C910 netlist is actually like the HDL. They've published a HDL for a version of the C910 that's used in the BeagleBoard Ahead. But they did that CPU core on a pre-ratified version of the vector instructions, right? And I think it's a testament to the open source world that they figured out a way to introduce T-head vector into upstream GCC, right? So you can, compile the vector instructions for the C910. But in developing for both, right? When you, we're working in the Linux kernel and you're working with high level languages. I mean, for the most part, you don't notice if you're running on ARM or RISC-V until you try to find some, binaries or tools that aren't built for it. And, 2 years ago, I think, it's really hard to find a lot of stuff built for RISC-V, 64-bit. And you really had to kind of deal with a lot of people that hadn't really tested anything on RISC-V. And there's still a handful of cases where you run into issues, but it's become few and far between. I think Debian is building SID now regularly on RISC-V, and it's a pretty broad set of packages. The support inside of Yocto is for RISC-V is stellar. And I think for people that don't really know why RISC-V is important, right? There's opportunities for people building processors to differentiate highly within the processor itself, but still run compatible binaries. And that's just magic, right? So I think you're going to see a lot of these custom CPU instruction set architectures. I mean, there's always going to be some, right?
Yeah.
But I think the rate of seeing them is going to go down drastically, because now you can still differentiate in your instruction set architecture for specific things, but you can have binaries that just run, and that's really the magic of RISC-V. It's so it will eventually dominate the instruction set world, not needing to pay for instruction set licenses. I think you'll see more and more CPU vendors that are delivering CPU IP for people to put in other things. Like, besides just the kind of the big RISC-V folks, you're going to see more and more of these CPU cores become available for licensing that use the RISC-V instruction set.
Yeah. So any resources to learn about Beagle or other aspects of BeagleBoard.org, and for who's kind of curious about getting into the community?
The first one, I'd just send everybody to docs.beagle.cc. So that's our documentation site. It's a Sphinx-based project. Always looking for community volunteers to help extend that, right? It's all managed through, Git repositories and, CI-based publishing. So you can build a fork and edit the documentation, see the updates. And there's a lot of to-dos in there. And, we really want to, improve our, introduction to Verilog, introduction to, the RISC-V architecture. Right. So, we did some kind of basic things where you would, kind of create some, your first, assembly program in RISC-V and call Linux syscall functions.
unfortunately, the last part of our discussion with Jason, we lost due to technical difficulties. Apologize for that. Thank you, Jason, for coming on the podcast. We enjoyed our discussion with you. And thank you to the audience for all our listeners. And if you have any feedback, please contact us at the many places we're available. We'd love to hear from you. Until next time, thank you.